Hello, everyone. Welcome. Thank you for attending this talk. Today I'm going to talk about a small but handy tool called syspatch. So quickly, who am I? So my name is Antoine. I'm known as AJ Couto or AJA at openbsd.org. I'm also part of the GNOME Foundation, and I mostly work on anything that helps me put OpenBSD into production. And for work, I'm head of SRE at Vente Privée. So what are we going to talk about today? Syspatch. Syspatch is both a tool and a build framework for patches. The main tool is basically a very small shell script, 220 line of code. And then we have the build framework that's under user source, the distrib syspatch, which is the usual source tree of your OpenBSD installation. That's mainly BSD makefiles that replicate what the release build process does on OpenBSD, as well as our ports tree. During this talk, I'm going to talk about binary patch. That's not really accurate because we're not doing binary diffing, but we're actually providing new version of binaries, libraries, etc. It's just easier to refer to them as binary patches, though. So, first of all, a little bit of history. Anyone who had to actually maintain OpenBSD boxen in production, more than a dozen of them hit this horrible requirement is that you cannot easily keep your system up to date. What I call up to date is not upgrade from one release to another, but just to keep up to date regarding security and reliability patches. So up until syspatch, you had basically two solutions. Either you CVS up and then you have to recreate a complete release. Of course, you have to do that to do everything manually. You have to use Signify to verify that the actual stuff that you download is valid. So the two different things you could do is build a release from scratch, CVS up from stable, or you keep the for example, 6.2 release and you manually patch it, and you build only the small part that you want it to be patched. The big issue with that is that if, for example, you have a security issue in your libcrypto, then of course you will rebuild it with the patch. That will install a shared libraries, but also a static library. The problem with static library is that anything in the base system that is actually using this library will not be rebuilt. So basically you're like half patch, really. So the only real way was to build a complete release from scratch, and that's a huge pain because that means that if you want to update a group of machines, then you have to do a really, really big upgrade, which is like the same, basically the same thing that you would do from one upgrade to one release, to a release plus one. So it was really tedious to maintain boxen. A few years ago, I was hired in a company called mChair. The company, one of the company's job was to put OpenBSD machines into production, both servers and workstation. So we had a huge pool of OpenBSD machines to maintain all over the globe. And of course, using official update facility was really tedious. So we came up with a tool to provide binary patches for the OpenBSD base system. The tool was based on the package tool. Like when you have a new patch, you just install the package. There was two issues with that. While it works relatively fine, it really abuses the package tool framework. Also, you will get mismatch binary, mismatch signatures in your packages when you upgrade to a new release. Let's say, for example, you upgrade libcrypto using a patch, then the package tool framework will record the checksum of the binary. Of course, when you later upgrade to the new release, then the package will still be installed, but of course the library will have changed. So there were all kind of stuff like that that were not really, really nice, I would say. So we come up with a small wrapper script called OpenUp, which is again a shell wrapper that we use to keep both the base system and the package up to date. And it's a wrapper because it was doing some stuff around behind the scenes to deal with checksum mismatch and stuff like that. So it works nicely. It was a bit ugly, and the main issue was that it was not official. So while there are a few OpenBSD developers hired by this company, it's still not an OpenBSD provided way to stay up to date. So now, situation today. So syspatch landed in OpenBSD on September 2016. It was the result of a hackathon in Cambridge. And that's a joint work between Robert Nagy and myself. The first supported release was OpenBSD 6.1, so that is the previous release, since we're at 6.2 today. So this tool only makes sense on official releases and kernel. You cannot use it if you're using like current or if you use it using stable. It's really meant to be an additional layer on top of a regular release. As of today, we support AMD 64, i386, and ARM64. We only support the last release. So that means that as of today, we don't support 6.1 anymore, although it is still supported. Patches are still available, but as CVS patches. Reason for that is a lack of manpower. And also what's important is that this tool is really a very small and stupid tool, so we really only want to use it to be up to date regarding security and reliability. It's not a new release upgrade tool. And why a shell script? Well, basically because everything we had to basically implement this feature were already in the base system. We just had to orchestrate them. So shell script. Before coming up with syspatch, we started looking a bit about what the others were doing. So in Linux, most of the time, everything is a package. So you don't really have to deal with that. You can run your DNF upgrade or apt upgrade or whatever. As I said, our intent was completely different. We don't want to be a release upgrade tool. We want to be a maintenance tool. Also, sometimes rollbacks are tricky when everything is a package. So then we looked at FreeBSD. To be honest, we've been jealous about FreeBSD update for quite a long time. We looked into implementing it, but that was quite complicated, much too clever, basically, for us, or at least for me. Also, it's very slow. It's horribly slow. And it's also a tool that will basically allow you to upgrade to a newer release. And so that's something we didn't want to do. And that's also is part of the complication of the tool. And regarding NetBSD and Dragonfly, as far as I know, it's source only. So syspatch. As I said, syspatch is really, really simple tool. You have 4 options that we will detail later. But basically, if you run it without any argument, it will install all the missing patches automatically. You don't have to pass it any option or anything. So it's just a small utility that will basically fetch and install binary patches and rollback, of course. Within the script, we implemented a small unpriv function. This function is used to lose privileges while doing some sensitive stuff, like going online or like doing cryptographic verification and stuff like that. So it's really stupid. We're using our own SU to do that. We drop privileges to a user called _syspatch, and then we do the dangerous stuff. That's exactly what the OpenBSD installer does, and we wanted to mimic that behavior. We also, well, you may be able, you may want to pass an argument, to this function, like you may want to, as an unprivileged user, go online, but of course you want to have the right to sometimes download something and write it somewhere. So with the -f function, the privilege, the losing of the privilege will happen after that the file has been created. So as I said, everything that's network related or crypto related will be done using this function, which is basically what we do in syspatch to fetch the SHA-256 signature file. So let's look a bit about the options. So we have a syspatch-C. That's basically check. So check what the what available patches are around. So what it does, it will fetch the signature file. We're using the command that was in the previous slide. It will verify it using signify, and then it will parse and compare what's inside that signature file to the installed patch on the system. And from that, it will build a list and display what's missing. Nice thing to note is that it's automatically run by our RC system once you upgrade to a new release. So that means that you will see in your G-message output if you have missing patches, and it will send a mail to root as well. We have the -L option, so that's to list the actual installed patch. It's a really stupid function. It will just look into a specified directory, that's var syspatch, and see if there's anything there. If there are, that means that we have patches that are installed on the system, and in this case, it will list them. Now we have syspatch without any option. As I mentioned, that's what will install all the missing patches on your machine. So it does a few checks before. It removes anything that doesn't match the actual release, and that's stored under var syspatch. The hierarchy there contained the actual CVS diff patch, so you can know exactly what the patch does. And it also contains the rollback patch. If something bad happened on the machine, you can easily roll back using that. But there is no garbage collection between releases. Like, for example, you have 10 patches installed on your machine, you upgrade to a new release, then this directory is still full of the old patch and rollback files. So the first thing that syspatch does is remove all the non-matched stuff there. And then it will compare your installed patches against the available one using pretty much the same function that used to list and check for patches. And then it will loop, doing the unpriv download and verification of the remote tarball that are on our mirror server. It will do a few checks, like make sure that we're writing on the local file system, not on NFS, that we have enough space, that the file system is not read-only, stuff like that. And from there, we pick the actual list of files that we're going to install from the tar.gz, and then we create a rollback tarball using the actual files that are on the system. And then we save, once we have done that, we save install the patches that are contained, the files, that are contained in our patch. We're using install -S, which is the safe install that unlinks the existing target before installing a new file. And then at the end of the run, if a new kernel was installed, that is, if it was a kernel patch, then we run reorder kernel. Reorder kernel is what we call call on OpenBSD. So it's pretty new feature that I think it landed like 6-8 months ago. It means kernel address randomized link. And it's basically a randomization feature that we added to our kernel. It shuffles the object linking order, and it does that at every reboot. So like each kernel that you guys run on OpenBSD are completely different one from another. So like the internal delta between functions inside the kernel are not where one would expect them to be, which makes some particular case of tags way more difficult. It's different from KASLR, which is what I think they're doing on Linux, but it has a similar goal. So basically, we don't need to load the kernel in a random location because the kernel itself is randomized. So that's the main difference between CARL and KASLR. We have the -R option, which will roll back the last installed patch. It's important to note that you cannot choose which patch you want to install. All patches are cumulative. If you want to roll back a patch, you have to roll back the entire sequence of patches that were before this one. So that's why you can only always roll back the last installed one. So what it does basically, it does the same kind of checks as we do when installing patches. And then it will get the rollback tarball from the var syspatch directory and extract it. And then, of course, remove the old syspatch directory, and then we relink the kernel if needed. And we have the minus capital R, which is basically remove all the patches. We had a few use cases in the past for that, so that was it was implemented. And of course, as anything in syspatch, it stops at the first error. So that's how to basically handle the patches. So let's have a look at how the process and the building of patches works. So first of all, someone noticed an issue with the code. So they will tell the developer, your code sucks or whatever, has a security issue in it. So we create a fix. We get, of course, validation and review. It is committed to current. And then Bloom will backport it to stable and create the initial errata file. TJ will then review the patch, write the W changes on our website, and we'll create an announcement. Then Theo will sign the patch. Only a handful of people are actually able to sign the patch file. Then Robert will build the patch using the signed patch file. And of course, then we test it and then make it available on our mirror. That's roughly our process for dealing with errata, but it's not set in stone. Can vary from time to time. So that's actually on AMD 64 and i386. Those are actually the build machine for syspatch. So they're quite small. They are built on machines that don't have any access to the internet. And for each patch, we do a complete rebuild of the release. I will go into that a bit later. There are different types of patches. We have kernel, we have userland, in which case we build an entire release, or we have Xenokara or Xorg implementation, and in which case we rebuild the complete x.org. Of course, all the patches are installed on the build machine, and all the result of building release out, patched release will be put into a fake root directory. The patch are created by basically diffing our current fake root with the previous one. And that's how we know what's changed between the release and the patched one. Yes?
The network between how you get the patches on there.
USB. And yes, and the initial fake root directory is just the extracted official release. So we have a makefile for that, BSD syspatch8OpenBSD. I won't go too much into the details, it's not interesting. But basically, we stripped a bit what the OpenBSD release process does, as well as some part of the ports tree, and we assemble them into this file. So we fetch and verify the patch with Signify. We create a fake root using the no perm option because we don't build as, we do build as root, but we are losing privileges quite early. So when we install file, we need to be able to install them owned by root, etc. So we're using a no perm mount option for that. And then we diff the current built fake root against the former one and create the syspatch tarball. So the main issue we had when we first started implementing syspatch is that on OpenBSD we don't have reproducible builds. There's no effort whatsoever into that right now. So we didn't look for a reproducible build, but we looked for what I call deterministic builds. That is that we know that if we build this release on one machine and that release on another machine, we will end up with at least the same set of build options. First issue we had was with the archiver. We had to implement the D flag, the deterministic flag, to prevent some randomness in the archives. For example, we hardcode UID, GID, and mtime to 0, and the mode to 644. Otherwise, it could be completely random, and we had difference in like each and every archives. So that was easy to fix. There was a few requirements here and there to use that new options, but that was an easy fix. Then there was the timestamp of the actual archive, which were obviously different for each build. The diff.sh script that I mentioned is actually using CMP for comparison of the files. And we can actually use a 34 bytes offset to skip the timestamp index. We were actually quite happy to see that it was so easily possible. So this problem was also very easy to fix. Besides static archives, we also had a shared object. On OpenBSD, we rebuilt all the shared objects in a completely random order. So, of course, you can imagine that when you're diffing one release with another one, that, again, everything is different. So what we did is that we basically told syspatch to use readdlf on the shared object of the previous fake root, the previous build, get the linking order from there, and then apply it exactly in the same order when we build a release with a patched release. So that was a bit tricky to get, but in the end, it actually worked fine. In the middle of implementing syspatch, we moved from GCC to Clang, at least on AMD 64, i386, and ARM64. And we hit a few bugs that were Clang related, like the assembler does not properly set the dot file directive when compiling assembly files. So it was missing from the object, which basically prevented readdlf to see them. And if they can't see them, then we can't have the link order. So there was, I don't think it has been fixed upstream, but there is a bug report about it. We also build most of our stuff with -G, and sometimes it's not 100% reproducible. The location list section changes. So this particular issue is not fixed yet. What you end up basically is that you have a lot of false positives that you have to manually edit in the plist of the syspatch. It's still under investigation. We have no idea where this actual non-deterministic thing is coming from. Then we had the funny stuff with Perl. The configure test for long double implementation details probes the content of long double length, and that gets stored in the config module. But some of these bytes are currently pretty much random and vary between builds. Because of their long are only 80-bit, and the remaining bytes are like uninitialized. So we had again, it was not always the case. It was completely random, and it was a hard one to track down. But finally, we saw that it was fixed in Perl a few months before we started looking into it. So we just backported the patches. There was also the case of manual pages created by Perl. For that, we didn't come up with any solution yet. The diff.sh script uses said to remove the timestamp header. Then we had a few funny things like time and date that were in several pieces of code within the OpenBSD source tree, like to display the build date or whatever. So this one was easy. We just removed it from the code. Well, I mean, what use does it have? And also something that was really, well, something that was really unexpected is that patches aren't built on the release machines. The release are actually built by Theo. The patches are built by Robert. So they're not built on the same machines, obviously. And on OpenBSD, we don't have any automated garbage collection of old file. Like, for example, if we remove a header, then nothing will automatically remove it from the system. You have to do that manually. And we realized that actually Theo's machine had a lot of header that we didn't have, that weren't cleaned. I mean, basically that doesn't introduce any issue. But in this case for Perl, Perl actually picked up a different option because the header was there. So of course the final binary was completely different. And of course that specific issue is only relevant for the first syspatch, since for the second one we compare to our own built release. So what do we want to do in the future? So far the tool is very nice. It works really nicely. It's super simple. What we want to do is support more architectures, obviously. I would really like if we would be able to support the current release and the previous one, so at least you have patches for an entire year. That issue is, again, not technical. It's just that we don't have the manpower to do that. And something I'm hopeful as well is to pave the road for stable packages. We do have stable packages as part of the ports tree, but they're not built. So it's kind of a pain to actually maintain these. And it would be also a bit nice to have a more verbose output when listing syspatch, like listing installed one or the available one, because the name are a bit tricky. It doesn't always tell you where the actual patch is within the source tree and what it does. I mean, 002 underscore libSSL, okay, you know that's something under libSSL, but you have no idea what the patch fixes. So it would be nice to have that. And something else as well is that currently when we install kernel patches, a kernel patch is not a new kernel, it's just the new object file that were modified. So that means that we can ship really small patches. And your kernel will be recreated anyway by the CARL pre-order kernel mechanism. So that's why we only ship the differing object file. The problem we have is that on OpenBSD we have a different kernel for SMP machine and single processor machines. So that works perfectly fine, but if you want a VM, for example, you install it on a single processor machines, you patch it, and then you want to upgrade your VM to dual CPU, 4 CPU, 8 CPU. Then syspatch, then the next patch, syspatch will get a kernel patch that will try to build against MP machine, because you are now an MP machine, but your installer will only have installed the single processor object for kernel linking, and boom. So yeah, so I hope that one day we can have one/BSD for both MP and SP machine. That's pretty much it. Off topic, we are hiring, so if you're looking into development, operations, whatever, come talk to me. We're hiring all kind of different profiles. Any questions? Yes?
The patches are not cumulative, right? So if you have like 1, 2, 3, 4, 5, you need all of them.
Yes. You can't pick one or the other.
Okay.
That's by design. We thought a lot about it, but it's just way easier to do it this way. Yes.
Tell me if any process needs to be restarted?
Sorry?
Tell me if any process needs to be restarted?
No. We know how to do that. I would very much like to implement it. But I'm not sure how to integrate it within OpenBSD itself yet. There is a solution for it. I would like it personally, yeah. Yes? Choose.
What is your feeling about people who put syspatch in a cron for automatic?
Whatever, man. I mean, it's it's your box. I don't know. It's not a question I can answer. I mean, it really depends on your environment. I mean, if usually patches are really well tested. Of course, we can screw something up. I don't see what I do like is having syspatch check in cron, but apply it. Most of the time, you have to do something after you apply your patch. Like you have, I don't know, you have a libcrypto or whatever. You have to restart your daemon using your library anyway. So, yeah.
Sorry for my English. What's happened if I try to start syspatch and then I have a problem with network? What I have to do?
If you try to restart syspatch, oh, if you have a problem, okay, so the question is what happens if during the run of syspatch you lose the network? Okay. If anything happens between, at the moment of installation of the patch, and if any error occurs, then it will stop and roll back. So if you lose the network, it's not installing anything, so it will just hang whatever, then you can Control-C, and there is a trap handler that will handle everything. So it's pretty safe in that regard. Of course, if you unplug your machines, then... Okay, I think we're done. Thank you very much for your attention.